Today we're going to be talking about lesson 5.1 on ratios and rates. So you're going to recognize some of these terms from our chapter 5 preview exercises. So a ratio is a comparison of two quantities using division. So we can write that as a fraction 3 to 4 using the word 2, 3 to 4, or with the colon 3 to 4. A rate is a ratio of two quantities with different units. So again, comparing two different quantities, but this time they have different units. So 60 miles to 2 hours. A rate with a denominator of 1 is called a unit rate. So 30 miles to 1 hour or 30 miles per hour. So that per or each tells us that it's a unit rate. So here we're going to look at the first few examples. So there are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. So in example 1, find the ratio of females to males. So if we look at number 1, we have 60 females to 45 males. So we have 60 to 45. Now, we need to simplify this as much as possible. We know that these are both divisible by 5. So we would have 60 divided by 5 is 12. 45 divided by 5 is 9. We can now see that each of these is divisible by 3. So 12 divided by 3 is 4, and 9 divided by 3 is 3. So 4 to 3 is the ratio of females to males. In example 1, find the ratio of females to total passengers. So we know that we have 60 females, and we're going to add males and females to get the total. 45 plus 60 is 105, and we need to simplify. So again, we can see that these are both divisible by 5. 105 divided by 5 is 21. These again are both divisible by 3. 12 divided by 3 is 4. 21 divided by 3 is 7. So the ratio of females to total passengers is 4 to 7. Now, as we look at the third one, it says the ratio table shows the distance that the International Space Station travels while orbiting the Earth. Find the speed in miles per second. So we can take any point on this ratio table to write the speed in miles per second. We know that any point on this table, it will be the same because all points on the ratio table are equivalent ratios. So I'm going to start here with 14.4 divided by 3. So 14.4 miles for 3 seconds is going to be equal to how many miles for 1 second? And here that term per second comes in because we know it's going to be a unit rate. So 3 divided by 3 will give you 1. So 14.4 divided by 3 will give us our answer. So go ahead and divide 14.4 by 3 at this time. We see that 3 can go into 14 4 times to make 12. When we subtract, we get 2 left over. Bring down a 4, 3 goes into 24 8 times, and we bring up our decimal point. So this space station can go 14.8 miles per second. As we look at the next set, it says a complex fraction has at least one fraction in the numerator, denominator, or both. You may need to simplify complex fractions when finding ratios and rates. So what this is saying is that you might have a fraction in the numerator and a fraction in the denominator. Now these often look kind of scary and we kind of panic because we think we don't know what to do. But keep in mind that that fraction bar tells us to divide. So essentially this is saying 1/2 divided by 1/4. So we can rewrite that like this. Now keep in mind we can't divide by a fraction, but instead we multiply by the reciprocal. The reciprocal of 1/4 is 4 over 1. 1 times 4 is 4, and 2 times 1 is 2. 4 over 2 reduces to 2. So we could say here that the speed might be 2 miles per minute. Now, if we look at this next one, you use the point 3 and 1.5 to find the speed of the subway car. Does your answer change? Explain your reasoning. So again, if we use this information, 3 over 1.5, this is like saying 3 divided by 1.5. We would first snowball this. So 3 divided by 3/2. We would rewrite as a multiplication problem using the reciprocal. 3 times 2 is 6, 1 times 3 is 3, and we know that 6/3 is the same as 2. Now we can see here that we ended up with the same answer both times. So does your answer change? No, our answer does not change because the subway car is going to go the same rate of speed at all times. Here we have you mix 1/2 cup of yellow paint for every 3/4 cup of blue paint to make 20 cups of green paint. How much yellow paint and blue paint do you use? So how much yellow and blue paint are we going to need to make 20 cups of green paint? So we know that our ratio is going to be 1/2 cup of yellow plus 3/4 cups of blue is equal to the number of green paint. So first of all, our goal is to find out how much paint would this be. Well, we know that 1/2 is like 2/4 plus the 3/4 because we have to have a common denominator to add and subtract is 5/4 cups. Now we need to divide 20, our total, by the amount of parts in our ratio. So we have 20 over 5, over 5/4. So 20 to 5/4. So now remember, this is that complex fraction. We use division. Since we can't divide by a fraction, we instead multiply by the reciprocal. We can cross cancel if you'd like. 20 divided by 5 is 4, and 5 divided by 5 is 1. 4 times 4 is 16. So this tells us that we are going to need 16 parts of each part of the ratio. So if we're asking specifically how much yellow and blue paint do we need 1/2 times 16 for the yellow paint, and we need 3/4 times 16 for the blue paint. Remember that whole numbers always go over 1, and we can cross cancel. 1 times 8 is 8. So we're going to need 8 cups of yellow paint. For the blue paint, we again can cross cancel. These are both divisible by 4. 3 times 4 is 12. So we need 12 cups of blue paint. Now remember that our total is supposed to be 20 cups of green paint. So if we add 8 cups of yellow and 12 cups of green, or 12 cups of blue, we end up with our magic number of 20. So our answer here would be we need 8 cups of yellow paint and 12 cups of blue paint. Now this is very much like those tape diagram problems that we looked at earlier in the week. So we can use those same methods to help us answer the questions like these.